You're welcome, my dear student in Prep 1 in this new episode from your program Madrasa على الهواء. Today we're gonna talk about the chemical formula. Chemical formula. Chemical formula. What's meant by chemical formula? Chemical formula, it is formula, صيغة, that represents the number and the type of the atoms in a molecule. Again, what's meant by chemical formula? It is a formula that represents the number and the type of the atoms in a molecule. As what? As you see, Al2O3. This is a chemical formula of what? Of aluminium or aluminum, American and British, the same. Aluminium oxide. This is a chemical formula of aluminum oxide. It has two types of atoms, two types of elements. Number one is aluminium, number two is oxygen. This is the type of atoms. And number. This is one molecule. Contains two aluminium atoms and three oxygen atoms. Two aluminium atoms and the three oxygen atoms. So I can say that it is Al2, O. This is a chemical formula. It is a formula that represents the number and type of atoms in a molecule. Okay. What are types of compounds? We have many types of compounds. But before types of compounds, I must talk another time, for a short time, about the chemical formula. To write chemical formula again as Al2O3, what I must put in my consideration? Number one, any substance, any atom, any element represents or symbolized by two letters. I must put the first letter in capital and second small. If these two letters are the symbol of one element, I must write the first one in capital letter and the second small. Now they are two elements. How can I know? Because there are just two capital letters. A is a capital letter here, O is a capital letter, so Al is one element, O is another element. Okay. Number two. 2 here is for aluminium, Al. 3 here is for oxygen. Okay. Another one. If I say here 3Al2O3, what does it mean? Number one. 3 here means number of molecules. Number of molecules. 2. Number of atoms of aluminium. 3. Number of atoms of oxygen in one molecule. So it means here Al2O3, this is the first molecule, and Al2O3, the second molecule, but they are 3. Al2O3, the third molecule. So, if I ask you, my dear students, how many atoms of aluminium in this formula? Here, 1, 2 in the first molecule, and 2 in the second, so they are 4, and 2 in the third, so they are 6. And I can say 3 times 2. So here there are 3 atoms of aluminium. And how many atoms of oxygen? As you notice, in just one molecule there are 3. In 2 molecules, 3 and 3, 6. In 3 molecules there are another 3, 3 and 3 and 3, 9. And I can say easily 3 by 3 gives me the number of atoms of this type or this element in all the number of molecules. 3 by 3, 9. Okay. Second notes. It's very important. I must write the positive on the left. The positive, metal or maybe hydrogen. Negative on the right. Positive. I must start with positive, then negative. I can't say O3Al2. No, it's wrong. I can't write ALO. No, it's wrong, because O here is not, it doesn't represent an element because it's small. I must write it capital. I must write AL first, A capital, L small, O the second. Okay. And I can't write Al3O2. Is it wrong? Yes. Big mistake. Why? Why? Because Al3 here means Al, Al3. O2 means OO. And as you remember, my dear student, the valency of Al is trivalent. It gives 3 electrons, and another one gives 3, and another one gives 3. While oxygen, its valency is bivalent, -2. And if you multiply, if you subtract this from this or add, this will remove this, this positive will remove this negative. Okay, this positive remove this negative, this positive to remove this negative, and now we have 1, 2, 3, 4, 5 positive. It can't be like that. The valency of compound must be 0, must be 0. So it must be Al2, 2 atoms of aluminium combines with 3 atoms of oxygen. Why? Because Al gives 3. Positive 6. 1, 2, 3, 5, 6. 1, 2, 3, 4, 5, 6. O3 means O, O, O. O negative 2, O negative 2, O negative 2. So it will be -6. Positive 6 and -6, the valence will be 0. So I mustn't write this formula Al3O2 wrong, but I must write it Al2O3. Okay. Another notes, my dear student. You have noticed that Al, aluminium, its valency is trivalent. Oxygen, its valency is divalent. So I must write 2 here. But the formula of Al2O3 aluminum oxide, 2, the valency of oxygen, here is behind what? Behind aluminium. While the 3 that represents valency of aluminium were behind what? Or sorry, below what? Below oxygen. As this. Okay. So here in the compound, I must write down the number that represents the valency of the element, okay, below the other atom, the symbol of other atom, okay. This is aluminum oxide, okay, and I can write a lot of them. Calcium oxide, Ca, calcium, C capital is small, oxide, O. Which one I must write first, calcium or oxygen? Yes, calcium, Ca. C capital is small. Then oxygen. Why? Because calcium is positive, oxygen is negative. Okay. Calcium has what? Has 20 electrons. 2, 8, 8, 2. So it will lose 2. Lose 2 means 2 positive. Oxygen has 8 electrons. 2, 6. So it needs 2 electrons. It gains 2. It will be -2. Positive 2 with -2, they cancel each other. So I need just 1 calcium with 1 oxygen. CaO, formula of calcium oxide. In another way, calcium valency is di, oxygen valency is di. So these two will be under calcium. This 2 will be under oxygen. So it will be Ca2O2. 2 cancel 2, so it will be CaO. Another one. Calcium nitrate. Calcium nitrate. Okay. Nitrate N capital O capital 3. Its atomic group, and this atomic group has valency of -1. Calcium C capital is small, and its valency is 2, divalent or +2. So which one must be first? Yes, okay, Ca, very good. Then NO3, but now Ca gives 2. NO3 atomic group, negative atomic group, it will be -1. This positive cancel this negative, but the whole valency of this compound will be positive. It can't be like that, because the valency of a compound must be 0. So I have to bring another molecule of NO3 to be -1. So this positive cancel this negative. How can I write this? Now I have just 1 Ca and 2 NO3. So I will write it Ca just 1, NO3 by 2. That means 2 NO3. Can you calculate, my dear students, how many atoms of calcium in this molecule? 1. Yes. How many atoms of nitrogen? In here means 1. 1 times 2. Just 2 nitrogen. How many oxygen? 3 by 2. 3 in just 1 molecule of nitrate, but here I have 2. That means 3 plus 3. Okay. And in another way, calcium, its valency is di. Nitrate, its valency is mono. So I must 1 below calcium, and I must write 2 below NO3. So it will be Ca NO3 by 2. Okay. Now let's go to another topic, types of compounds. What are types of compounds? As you know, my dear students, if I have positive and negative, it will be compound. In one condition, valency equal 0. Number of positive equal number of negative charges. Okay. So, what are types of compounds? Number 1, acids. Number 2, as you see on the monitor, bases. Number 3, oxides. On the monitor, please. Types of compounds, acids, bases, oxides, and number 4, salts. Again, types of compounds, acids, bases, oxides, and salts. Let's know each one of them. Acids. What are acids? They are substances that dissociate, here means dissolve, okay, in water, producing positive hydrogen atoms. Positive hydrogen atom. Like what? Like hydrochloric acid, H capital, C capital, L small. Hydrochloric, H positive 1, Cl negative 1, so it is a compound. Why? Because it comes from combination between positive and negative, and this valency of this compound is 0. They cancel each other. Okay. Here, hydrogen is positive, Cl is negative. If it starts with hydrogen, except water, water H2O, except water. Any substance starts with hydrogen, positive hydrogen, it means that it is an acid. And when it dissociates in water, it produces positive hydrogen atom. Another one, H2SO4. H2 is positive, SO4 is negative atomic group. So when it dissociates in water, it gives positive hydrogen ions. It means it is an acid. So here, acids may comes from combination between hydrogen and non-metal, hydrogen and non-metal, or hydrogen and atomic group. Hydrogen with non-metal as hydrochloric and hydrobromic, hydrogen with bromine, hydrogen with non-metal. They are two examples for a type of acids which comes from combination between hydrogen and non-metal. H2SO4, sulfuric, not sulfuric acid. H2CO3, carbonic acid. Okay. HNO3, nitric acid. This type of acids comes from combination between hydrogen and atomic group. And you see on the monitor as hydrochloric acid, hydrobromic acid, sulfuric and nitric acid. What are, my dear students, what are the properties of acids? Properties of acids. Acids comes from what? From hydrogen, positive. This positive hydrogen atom, this positive hydrogen atom always have some properties. It causes what? Number one, they have sour taste. All acids have, as you see on the monitor, have sour taste. طعمها لاذع. As lemon. If you put drops of lemon on your tongue, oh my God, it's sour. Give reason why. That's due to presence of hydrogen positive ion. Number two, they change or convert the color of litmus paper into red. As you see on the monitor on this figure, it was blue litmus paper, but it converts or it changes red when it is put on or in an acid, in an acid. So acids can change the color of litmus paper into red. Give reason. That's due to what? Due to presence of hydrogen positive ion. Number two, bases, alkalis. They are substances which dissociate in water producing negative hydroxide ions. Negative hydroxide. It ends with OH. As I told you, my dear student, if it starts with hydrogen, it will be acid, yes. And if it ends with hydroxyl group, it will be base. It will be base or alkalis. Bases comes from a combination between any metal and hydroxyl group. And when it associates in water, it produces negative hydroxyl ion. All properties of bases comes from presence of negative hydroxyl ions. But what are types or what are examples of this type of bases? Number one, sodium hydroxide, calcium hydroxide, calcium divalent, so I must put 2 here, while OH is mono. Calcium hydroxide, magnesium hydroxide, okay, potassium hydroxide. What are the properties of bases, my dear student? But here you have to notice that formula of all bases end with OH group, as sodium hydroxide, potassium hydroxide, and so on. Properties of bases. What are properties of bases? As you see on the monitor, their aqueous solution, محلول المائي بتاعها, have a bitter taste. طعمها مر, bitter taste, as cantaloupe. They change the color of litmus paper into blue. Give reason. Why the bases have these properties? Due to presence of negative OH. The solutions have bitter taste. Number two, they change the color of litmus paper into red. We talked about acids, bases. Number three, the third type are salts. What are salts? They are compound that resulted from combination between positive metal, positive, any positive, maybe metal, maybe atomic group. We have atomic group positive, NH3, okay, NH4, sorry, and or maybe positive, this positive metal or positive atomic group with negative non-metal or negative atomic group. So as you see, maybe Na, it's positive, or maybe NH4, it's positive. Maybe Na with Cl, positive metal مع negative non with negative non-metal, it will be NaCl, it's salt. Another type, maybe Na with NO3 atomic group, positive metal, negative atomic group, it will be NaNO3, salt. NH4, maybe NH4Cl, atomic group with non-metal, it will be NH4Cl. Maybe NH4 with NO3, NH4NO3, salts. And the properties of salts, they don't affect on the litmus paper. While the last one is oxides. We have two types of oxides: metal oxides, metal with oxygen, and non-metal oxides, not metal like C or S with the oxygen as carbon dioxide gas or sulfur trioxide. My dear students, by this point we reached the end of our lesson today, and we hope to see you next week.